In the last video, we talked about showing that triangles are congruent, and we started with the idea that triangles have 6 pieces, 3 sides, and 3 angles. And we showed that we wouldn't need to show all 6 pieces if we have some shortcuts. And we even showed the shortcut called side, 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 which is that you have 3 pairs of congruent sides. So what I want to do now is I'm actually showing you right now. Those are the 4 shortcuts that you can use, but I kind of want to describe them a little bit so that way it's easier to understand what we're talking about. So let's go back to side, side, side. And with side, 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 we write down SSS. But the idea with side, side, side is imagine you're manufacturing these triangles out of like wrought iron metal. So you get these 3 pieces, one length of metal that is 6 inches, and another length of metal that is 7 inches, and another length of metal that is 8 inches. And you have to kind of join them all together. And when you join them all together, it creates this triangle that has a 6 side, a 7 side, and an 8 side. So then the idea is if they keep on giving you these pieces, 6, 7, and 8, and you keep on using those 3 pieces to create a triangle, every triangle that you make will be identical, right? They're going to be congruent. So that's the idea, is that those 3 sides lock into place. And then because of those 3 sides being 6, 7, and 8 every time, that you'll have all these triangles that are exactly the same. So the idea here is that if you have 2 triangles that have congruent sides or equal side lengths, then that means that they have to be congruent triangles. The whole triangle has to be congruent. Okay, so let's look at this next type of shortcut, which is side angle side. So now with side angle side, now we basically have a side length. I'll use my 6 again. An angle length of 7. Sorry, a side length of 7. And in the middle, which we call included, we're going to say that this angle is 40 degrees. Almost like a little L, but slightly off. So now the thing is, if they give you this little angle piece that has a 6 and a 7 on the sides and a 40 in the middle, and then you construct the 3rd side, not even really knowing what length that is, and they keep on giving you these angle pieces, a bunch of these. They give you another piece that's an angle piece. It's like this. 6, 7, and 40 degrees. Is this other red side, should it be the same as this first red side? And yeah, the answer is yes. And it should kind of make sense. Like you locked these 2 lengths are locked, and this angle's locked. So therefore, this 3rd side, that distance between there, is going to be locked. So again, if they give you a bunch of these pieces with the 6, 7, and the 40, you would make a bunch of congruent triangles. So that's called the side angle side theorem. So with side angle side, notice here that your angle is included. You say included, or in between the 2 sides that are given. Okay, our next triangle shortcut is called angle side angle. So with angle side angle, or ASA, now we're given a side length. We're going to call this 10. And let's say they just kind of put a little tiny side on here. And this little tiny side can be attached to a longer side. But all you do know is that this little tiny side is 37 degrees. And then they're going to give you another side here. Again, it's like a little, you can attach to that side and extend it. And let's call that 51 degrees. So now what you do is you take two side pieces and you weld them on here, and you basically just extend them so that they meet and create this new triangle, right? And then again, they give that same piece again, this little bracket piece that has a 10. Got a little piece on here that's 37 degrees. It's got a little spot here that's 51 degrees. And then you weld on this extra until it makes a triangle. And the questions is that congruent? And again, intuition should say, you know what, they are congruent. Because since this direction, this length is the same as this length, and this direction and this direction are locked into place. So when I extend them, make this triangle, it's going to give you the same extension on these two lengths. So these two triangles would be the same. So that's the idea of angle, side angle. Notice the reason they call it angle, side angle is because now the side is in the middle of the two angles. That's why you say ASA, or angle, side angle. The side is in the middle of the two angles. The side is in the middle of the two angles. Where on side, angle, side, the angle was in the middle of the two sides. Okay, the last one here is side angle, angle. And actually, I'm going to kind of wave my hands at this one and just say we can do the same idea as we did with the previous three. It's a little bit more complicated, which is why I'm leaving it to just you believing me that it works with side angle, angle. But in this side diagram, notice how it's the same number of pieces. We have two angles and a side, as the angle, side angle. Just now the side is not in the middle of the two angles. See, if this side were here, it would be an angle, side angle. But since this side is outside of the middle of these, you call it side angle, angle instead. Okay, the last thing I want to leave you with is with a couple shortcuts that do not work. So these ones do work. So what shortcuts do not work? So one shortcut that does not work is angle, angle, angle. That does not work to show that two triangles are congruent. And the best way to show, and this is a case where it's easier to show a counterexample of two triangles that have the same angles. So let's just draw. I'll do a 30, 60, 90 right triangle. Is that I can draw a bigger right triangle with the same angles. I can just basically take all three sides and make them proportional. It'll be proportional. So 60 and 30. In fact, I can even write some side lengths here. So let's call this one 1, 1.73, and 2, which is pretty close. I mean, this was the 1.73 is rounded off, but in terms of a 30, 60, 90 right triangle. And then this one could be twice as big. So this could be 2, 4, and 3.46, for example. And that doesn't work. I mean, even though those triangles exist, these two triangles exist, but they're obviously not congruent because the one on the right is bigger. And then one other one is if you have, and I'm just going to try to draw this the best I can here. Maybe, and they'll try to trick you by drawing them to where they look good. But let's say we go something like this. So this one actually has a longer proof of why these don't work. This is called angle side side. And we don't even usually say that because we don't want to cuss in math. So let's get rid of that. And we'll say that side side angle does not work. So side side angle does not work either. And again, it's a longer proof. You can look up some proofs on there on YouTube or on Khan Academy, and they'll show why that does not work. So these do not work. Okay, I'm going to put this down here. Do not use angle, 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 or side, side angle. Now there's one little special case of side, side angle that I want to show. And that's if it's a right triangle. So I drew two right triangles here, and how they'll try to trick you on these ones is that they'll give you the right triangle, and then they'll say these sides are equal and this hypotenuse is equal. And a lot of students will go back and say, well, that's a side-side angle. I see side-side angle's not in the middle, so therefore they're not congruent. But wait, there's more. Wait. Since it's a right triangle, if we had these two lengths for the leg and for the hypotenuse, we would find the third length here. And since these are equal, both these third lengths would be equal, which would now make it a side, side, side. So technically, because it's a right triangle, these triangles are congruent, even without those side lengths. So what we call this one is, since we had, at the very beginning, it's a right triangle, and we had these side lengths, we're not going to say side, side angle because it's right. What we're going to say is we're going to say, well, it's a right triangle, so therefore we had a hypotenuse, and we had the leg. So we call that HL, or hypotenuse leg. And that just tells you automatically that since it's a right triangle, it'll work because you have the hypotenuse and the leg. And that actually will give you 5 triangle congruencies, shortcuts.